All right, we're going to continue on with P7 notes and the quadratic inequalities. The first way we're going to look at solving a quadratic inequality is actually one of the nicest ways. It's called a graphing approach. So if you take a look at this quadratic, this parabola, we can easily see that when x is less than -2, the output of the function, the y value of the function, is positive. It's above the x-axis. If you plug in a -4 for x, the y value is positive. It's up here. If you plug in a -3 for x, the y value is up here. It's positive. If you plug in a -2 for x, you get 0. That's the place where it changes from positive to negative. So when x is less than -2, this function is greater than 0. It's positive. When x is greater than 3, the function value, or the y value, f of x, whatever you want to call it, the height of the function, it's positive. All right. Now, in between -2 and +3, f of x, or the value of the function, the output of the function, is negative. It's less than 0. Okay, so that's what we're going to be looking at. So you can use a graphing calculator to do this by plugging this in a graphing calculator. We know a couple things that we do know. We know that 4x squared minus 12x plus 7. We know that if we set that equation, y equals that, and plug that in a graphing calculator, we know that it crosses the x-axis at 0.79 and 2.21. It would, look something like this. We'll just say that's 0.79 and that's 2.21. It's going to be a parabola that goes like that. The y-intercept would be 7. Okay, but that's what it would look like. So then we can, if we know what the graph looks like, we can easily say when it's greater than 0, less than 0. When this equation right here is greater than 0, less than 0, or equal to 0. We know it's equal to 0 at these two values for x. So let's take a look at our first problem that we actually would have to do here. We have x squared minus 3x minus 10 less than or equal to 0. What values for x will make this less than or equal to 0? Well, what we're going to do is we're going to take a look at a graphical approach. So we would graph it, and if you don't have a graphing calculator, you might say, well, how am I supposed to do it? Well, you know that this factors into x plus 2 times x minus 5. So when we factor the quadratic into x plus 2, x minus 5, that has to be less than or equal to 0. And so I'm not sure why. Oh, it doesn't matter it could have been less than or equal to or just less than. So anyway, either way, you're going to factor it. And then basically we need to look for when will the output to this function be less than 0? Well, that's going to be when it's below the x-axis. So what x values that you would plug into the equation are you going to get outputs that are negative or below the x-axis? Well, that's obviously x values between -2 and +5. Anything you plug in between -2 and -5, the function value is going to be down here. It's going to be negative. So if the inequality says less than or equal to 0, it's between -2 and 5, and you have brackets to include -2 and 5. If it just says less than 0, then it's parentheses between -2 and 5, because we don't include the -2 and -5. And remember, we're looking for x values that cause the output to the function to be less than 0. And that means the y values to be less than 0. So here's one that says the exact same quadratic greater than or equal to 0. So what values for x will I plug into here so that the outputs will be positive or greater than 0? Well, obviously not between -2 and 5, but smaller than -2 is going to take me up there, and bigger than +5 is going to take me up high above the x-axis. So we know that the answer to this inequality, and it's greater, so it's an or, and it's going to be between negative infinity and negative 2, if you want to use interval notation, or it's going to be from 5 to infinity. And if it's greater than or equal to, we include the negative 2 and 5. If it's just greater than, we do not and have parentheses. So again, greater and less than. Remember back here, it was less than, and we had in between. It was in between negative 2 and 5. So it's greater than negative 2 and less than 5. All right, so the next one, we just did that one, right? Yep. So the next one is, hope you didn't get dizzy there, quadratic inequalities. Again, a graphing approach. You have to find the zeros. All right, so the first thing we're going to do is to find the zeros of this quadratic, we factor it. So it factors into 2x minus 3, and 3x times 3x minus 2 has to be greater than or equal to 0. And so basically, that means if you were looking at a graph here, you would be saying, well, it's going to be x equals 3 halves, so that's 1 1/2. That's going to equal 0 there. And the other one's going to be 2/3, which is like right there. And so we know that because the leading coefficient's positive, it's going to open up. So it's going to look like this. And if we want to know when it's greater than or equal to 0, we know that's going to be out here and out here. So that means it's going to be, x is going to be less than or equal to positive 2/3, or x is going to be greater than or equal to 3 halves. And that's what you have there in interval notation. The next one, we have a little more work to do. And again, we're using a graphing approach, but no calculator. So first thing we have to do is get everything over on one side so that it's a quadratic and it's set less than or greater than or equal to 0. So we have the quadratic less than 0 when we take the 9x to the left. We factored it into the two factors that you see here and solve for x. X equals 1/4, x equals 2 is what you do when you set those equal to 0. Now, obviously, this is an inequality, but why did I set them equal to 0? Because I'm trying to find where they cross the x-axis, the place where it crosses the x-axis. So now that I know that, I'll make a quick sketch of a graph, and we know that that's going to happen at 1/4. So that's like about right there. And at 2, which is right there, once again, we know that this, because it's positive 4x squared, it's going to open up. So basically, it doesn't matter how good your sketch is. It just has to go like that. You look at it, you answer the question, when's it less than 0? Obviously, it's obviously less than 0 when x is greater than 1/4 and less than 2. And there it is in interval notation. The next one, we have the same type of deal. We got to bring the 20 to the other side. We get the quadratic, and we factor it. This time it's less than or equal to 0. We know that it's going to cross the x-axis at 5 halves and -4. And so we go, here's -4, and here's, let's say, 5 halves or 2 1/2. We know once again, because that's 2x squared, right here, it's positive leading coefficient. The graph is a parabola that opens up. The x-intercepts are -4 and 5 halves. Again, it doesn't matter what your graph looks like as long as it doesn't have to be perfect. You know that this quadratic, the outputs to this quadratic are going to be less than 0 when you're between -4 and 2 1/2, because those outputs, the y values are all negative in between when x is between -4 and 5 halves. So your answer is x has to be between -4 and 5 halves. And it includes them because it was less than or equal to, so be careful on that. And so what happens if it's a cubic? If it's a cubic, it's the same thing if you use the graphical approach, because it's what you learned last year. You did this last year in Algebra 2. So you can see there's an x in all three terms that we're able to factor out. So that would have been x times x squared minus x minus 30 less than or equal to 0. And then in the next step, we can factor x squared minus x minus 30 into x minus 6x plus 5. And of course, the zeros of that function are 0, 6, and negative 5. So you have these three places it crosses the x-axis, and you know what it's going to look like because you know in behavior rules it's an odd degree polynomial. The leading coefficient's positive, so the end behavior is going to be down on the left side and up on the right side. It goes to negative infinity and it goes to positive infinity on the right. And so we know it has to come up from negative infinity here, and then it goes through negative 5. It's got to come back down through 0. That's going to go back up through 6 and go on to positive infinity. So from our knowledge of what we learned last year in Algebra 2, we know that the sketch of the graph will look like this. Once you have the sketch, pretty easy to determine when is it less than or equal to 0. Obviously down here, and that means when x is less than negative 5. So from negative infinity to negative 5, it's less than 0. The easiest thing to do is just come across, and it's below 0, below the x-axis, so we know it's less than 0 from negative infinity to negative 5. From negative 5 to 0, it's positive, so that doesn't work. From 0 to 6, it's negative. So we're going to put in from 0 to 6, and then from 6 to positive infinity, the output is positive. But we want to know when the output is less than 0 or negative. So here you have it between negative infinity and negative 5, and from 0 to 6. And we include all of those points, negative 5, 0, and 6, because it said less than or equal to 0. So 6 and negative 5 and 0 are all places that equal 0. And so now, in the next one, same thing. We've got to bring everything over to one side. It'll be negative 2x cubed plus 8x minus 1 less than 0, but we don't like that first term to be negative. So we're going to multiply everything by negative 1 and get positive 2x cubed and a negative 8x and a positive 1, but we have to switch the sign around on the inequality. Now it's greater than 0. And now we have this inequality, this cubic. This cubic, you're not going to find the zeros by factoring, so you are going to have to use a calculator. So you plug it in your calculator, you find second calc zeros to find the 3 zeros, and on your graphing calculator, it should be crossing the x-axis just a little bit past 0 at negative 2.06 and at 1.93. And depending on if you use this right here, then it's going to look like this. And that's how you'll answer the question, because you're really answering the question here when you got it set everything on one side, and then in this case greater than or equal to 0. You could have done this one and this first one, and that would have been negative 2x cubed plus 8x when is less than 0. But what you have to understand there is that since the leading coefficient's negative, it would look like this. But now you're asking, when is it less than 0? So that's going to be at the same places that this one is greater than 0. So it all works. Here's some special cases. When is x plus 3 squared equal to 0? Only if x is negative 3 will that equal 0. What about x plus 3 squared greater than 0? Well, guess what? When you square a number, it's always positive, isn't it? But it just says greater than 0. So negative 3 would not make it greater than 0. Negative 3 makes it equal to 0. So you have to include, it's going to be everything but negative 3. And so the next one, when is it greater than or equal to 0? Everything will be greater than or equal to 0. Because no matter what you plug in, when you square it, it's going to be positive. And if you plug in a negative 3, it's going to be 0. But it's a greater than or equal to 0. So it's all reals. When is x plus 3 squared less than 0? Absolutely never. There's no solution there because it's either going to be positive or 0. And it's not less than 0. Less than or equal to 0 is only one number that works, and that's negative 3, because it makes it equal 0. Nothing will make it less than. And I'm going to stop at this point and do projectile motion in the last video.